Nice to meet you. I'm Katan Choktai and you're watching my YouTube channel School of Advanced Chemistry. I am going to explain chapter number 6, Reversible Reaction, basically the synthesis of ammonia and contact process, that is synthesis of sulfuric acid. So as far as this lecture is concerned, I'm going to give you the revision, a small quick revision about this topic, especially with the perspective of paper 2. Number 1, Haber process. It is industrial process that is used to manufacturing of ammonia, NH3. Ammonia gas is supposed to be formed. Ammonia is important for making fertilizers, explosive and other different chemicals. It helps to increase the agriculture production and global food supply as well. So that is a basic cause, that is a basic perspective of synthesizing ammonia. What are the raw materials? Nitrogen, hydrogen are the basic major main reactants. Nitrogen is obtained from air. Hydrogen is basically obtained from the cracking of oil or natural gas, or cracking of crude oil. And here is this one equation. So N2 plus 3H2, 1 mole of nitrogen is going to react with the 3 mole of hydrogen. A reversible arrow, don't forget to apply this one arrow to make 2 mole of NH3 gas. Nitrogen gas, hydrogen gas and ammonia gas. Now the basic and important phase is this one. We are going to talk about the condition of synthesis of ammonia. Here we are going to apply the pressure 200 to 300 atm pressure, that is supposed to be a high pressure to increase the yield of the chemical reaction. Temperature. As far as the temperature is concerned, we are going to use 450 degrees Celsius. That is not very much higher temperature. That is supposed to be the optimum temperature. It is optimum temperature at which both yield and speed are maximum. Speed as well as yield, both are optimum. As you know, this is an exothermic reaction. So if we are going to increase the temperature more, then yield will decrease. And if we are going to decrease the temperature up to the large extent, then speed will be decreased. So this 450 degrees Celsius is an optimum temperature to make maximum yield, to obtain the maximum speed. So that is the fixed one, that is optimum one, and so on. Here we are going to use a catalyst, that is iron. Fe solid is basically acting as a catalyst that is used. Why catalyst is used? To speed up the chemical reaction, just to speed up, not to increase the yield. Important feature. This reaction is reversible. Ammonia is continuously removed to shift the equilibrium towards right hand side, the side of the product. The gas mixture leaving the reactor contains ammonia, nitrogen and hydrogen, unreacted nitrogen and hydrogen, and newly formed NH3. As you know, this is a reversible reaction. So container is having all of the species, reactant as well as the product in that container. They all will be present. Next thing is cooling and condensation, liquefying ammonia for separation. Unreacted nitrogen and hydrogen are recycled back into the reactor. So these are the basically important features. These are the basically practical features in which we are going to obtain ammonia as well as nitrogen and hydrogen, that is the part of that mixture. But unreacted nitrogen and unreacted hydrogen is again put into that beaker, into that container, into that reactor for the recycling purpose. Use of ammonia. Ammonia is used for the manufacturing of nitrogen fertilizers. It is used to make nitric acid, and it is also used to make plastic and artificial fiber. and it is also used for the production of explosive through the passage of nitric acid. So that was the basic measure, a quick review how ammonia is formed, how ammonia is produced, and basically what are the basic major main conditions to synthesize the maximum yield of ammonia and within the smallest, lowest time span. Next thing is basically indirectly you can say that is eutrophication. Water pollution caused by the excess fertilizer, for example, nitrate from the fertilizer, sewage and industrial waste. So from fertilizer, from sewage and from industrial waste, we are going to have nitrate ion, nitrates, NO3, 1 negative ion. Phosphate ions from the fertilizers and detergent sewage. They creates basically water pollution that is actually known as eutrophication. What is that process? Basically nitrates and phosphate enter to the river or lakes. So due to their presence, algae grow rapidly and that is going to block the sunlight. That is why the sunlight is not coming to that water, so aquatic plants start to die. Dead algae decomposes. Basically when the algae is going to die, it decomposes the dissolved oxygen from the water. So oxygen level decreases in the water. That is why fish and aquatic organisms die. So these are the basically major demerit of nitrate and phosphate ions into the river, into the water. Next one is the chemistry of soil. Some crops require neutral or alkaline soil. Acidic soil is neutralized using the calcium hydroxide. If your soil is acidic, if there is an acidic rain on the soil, then you can neutralize it or you can alkaline it. You can make its pH more than 7 by using calcium, by adding calcium hydroxide in that soil. So calcium hydroxide addition into the soil will neutralize the acid present into that soil, and it will also increase the pH of the soil. However, if you want to just neutralize the acid into the soil, then there is no need to add this one. Then you will add calcium carbonate. This is a limestone. Limestone will just neutralize the excess solid or any solid present in the soil, but it will not change the pH of the soil above 7. So calcium carbonate maintain the pH of the soil till 7. Calcium hydroxide neutralizes the acid, as well as it is going to increase the pH above 7, and it may till 13 or 14. But here are some demerits. Calcium hydroxide releases ammonia from ammonium fertilizers. So calcium hydroxide is forbidden to use with the presence of ammonium fertilizer, for example ammonium nitrate, because it is a base. This is a base and it react with ammonium ion and it make ammonia gas. So nitrogen contents will be lost from the soil. The basic purpose of the fertilizer is to provide maximum nitrogen to the soil, but in this way, in this combination, the nitrogen is going to lose from the soil. Therefore, ammonium fertilizer should not be used in alkaline soil containing lime and so on. Next thing is fertilizers. What are the fertilizers? Fertilizers are the natural or synthetic substances. Those are added to the soil to supply the essential plant nutrients. I mean, you can say nitrogen, phosphorus and potassium are the essential nutrients for the plant to growth. So NPK rating is essential for all type of different fertilizers. Show percentage, 3 important nutrients. NPK rating basically tells us the basic major contribution of or the percentage of nitrogen, phosphorus and potassium. Function of NPK. Nitrogen's function is to grow of leaf, stem, and protein formation or protein synthesis. The function of phosphorus is for the root development. The function of potassium is to increase the production of flower and formation of more fruits. Here are the traces element. Those are also used in contact with NPK, calcium, sodium, magnesium, iron, and zinc. Come toward the next one, that is, I'm going to teach you the contact process. Basically, first of all, there is sulfur dioxide. So basically, what is the sulfur dioxide? It is a corrosive gas, acidic gas, when it is added into the water. When it is in contact with the moisture, it becomes corrosive gas. On dissolving with water, this SO2 gas becomes sulfurous acid. SO2 gas react with the water to make H2SO3. Sulfurous acid is supposed to be formed. The basic use of SO2 gas is bleaching agent. SO2 gas is used as a bleaching agent, especially for the wood pulp that is going to make the paper. The second function is it is going to act as reducing agent. The third one function is it is used as a food preservative. It kills bacteria and fungi. So there are basically, you can say, overall major, main, maximum 3 uses of SO2 should be in your mind. Next one, we are going to use SO2 to make sulfuric acid, and this process is called contact process, making sulfuric acid. What are the raw materials in synthesis of sulfuric acid? Number 1, sulfur, solid sulfur, air mean oxygen, water mean moisture or water liquid. So these 3 are the ingredients. Stage 1, there is the formation of SO2 gas when sulfur is roasted at high temperature. When sulfur is heated and it is allowed to react with oxygen, SO2 gas is formed. That is the first stage, and this reaction is irreversible reaction. So it is happening happily, easily, and so on. The second stage, very important stage, that is the main stage. Here is the formation of sulfur trioxide, SO3, and you can see that this is the reversible reaction. So all reversible reactions are going to have almost poor yield. Same is the case over here. SO2 is allowed to react with oxygen and it is going to make further next level oxide, that is SO3. But it's a reversible reaction, and as well as it is an exothermic reaction. The forward reaction is exothermic. Here we are going to use temperature 450 degrees Celsius as we have been used in the process of Haber process to make ammonia. Same temperature is going to be used over here, just keep in your mind. But this time we are not using the same pressure. We are just using maximum 2 to 3 or sometime no pressure. Just 1 atm, that is the normal atmospheric pressure. This pressure is not same as that we have used in Haber process. We use very much low pressure because high pressure need cost, right? Make it costly, and it is having no impact, no major impact, right? Because the number of mole of the gases on the left hand side is equal to 1.5 and number of mole of the gases on the right hand side is equal to 1. So there is no much difference between the mole of the gases. So increasing the pressure, yield is not going to be increased up to the very appreciable level. So generally there is no need to apply the high pressure. That is why, because if we are going to apply the pressure, the cost of the project will increase and it is not going to make a large impact on the yield of the reaction. Catalyst. Here we are using again different catalyst, not that is used in the Haber process. It is vanadium 5 oxide, V2O5, and it is also known as vanadium pentaoxide. So these conditions are used to make maximum maximum SO3 gas. The next stage is formation of oleum. Sulfur dioxide is not directly dissolved into the water because this reaction is too violent to control. So instead, we use SO3 gas. We dissolve SO3 gas into already made H2SO4. We dissolve SO3 gas into sulfuric acid, concentrated sulfuric acid, and H2S2O7 is formed. That is called oleum. I mean, you can say it is a sort of, you can say, or we can suppose it that it is a sort of an addition reaction. So how many hydrogens are there to how many sulfur are there to how many oxygens are there? 3 plus 4, 7. So just add these two molecules, and here is the formula of oleum. Now this oleum is dissolved and it is mixed with the water. It is not very much violent reaction. It is a normal reaction, and this is, you can say, the hydrolysis of the oleum, and oleum is going to change into 2 mole of sulfuric acid. 2 mole of sulfuric acid. So what has happened overall? We react sulfur with oxygen. We make the different gases that react with then water to finally make sulfuric acid. That is an overall reaction, and this procedure is called contact process, in which we can synthesize sulfuric acid. So that is all about these two basic main synthesis of ammonia and synthesis of sulfuric acid. Thanks for watching.